Okay, right. So I was thinking about what the non-occurrence. Okay, non-occurrence of nucleophilic substitution. Right. What is called the nucleophile? Yes. Anyone? Yes, Zain. What is mean by the nucleophile? By breaking CO bond. So you should be very careful about that. Why I'm speaking about the non-occurrence of the nucleophilic substitution, right? It never happens, right? Why the phenols, unlike the alcohols, the phenols are not undergo for the nucleophilic substitution reaction. That is the reason. Simply, I can say you can see the benzene, right? There is the CO bond. How they are getting into CO bond? Hmm? This is the carbon, right? Benzene. What is the benzene mean, sir? Six carbon is there, right? So this is the bond between what? CO, right? That's why they are telling it's a CO bond, right? Okay. So what is happening? So when you are speaking about this is what? Yeah. So when you speak about the CO bond, right? Not like other bonds. Here, there are, though it's what the CO bond is the sp2 hybridized. This carbon is sp2 hybridized. Not like other what your this alcohol carbon, right? Why we are telling is this is very strong and short. This bond is very strong and the short compared to your double bond. Your usual double bond, right? Your usual carbon carbon double bond is not that much stronger compared to the your benzene carbon carbon double bond. You know why? What is the reason? Yes, the benzene able to show what? The resonance hybridization, right? So they, because of the delocalization of this pi cloud, right? They able to form very strong, and short means what? The length also small. Very strong and short carbon carbon bond. This will never allow to us to break the CO bond for the nucleophilic substitution. That's why the nucleophilic substitution never happens in the phenol. Did you all understand? Okay, only Zain is there, right? Did you understand, Zain? Yeah, it's Shahim. What happened?
Go on, madam.
Did you understand?
Yeah.
Uh-huh. I was confused. You just send a message to him, right? Ask him to join. Wait, I also will share the message. You send. Okay. Right. So, and also, he came. He came. He came. Why? What happened, Shaheen? And the phenol, I already spoke about what it's able to produce what the resonance hybridization. So what is again? I'm just going to speak about this resonance hybridization. This CO bond, what will be happen? The lone pair will move. This will cleave, hmm? And you will get such kind of. Please by heart. Nothing to by heart. If you understand the sequence, you will understand. So once the double bond move, sorry, lone pair move, you can see the double bond and it will provide the positive. And this bond cleave, therefore it's a minus. This is already there. Then the minus will form bond and this next bond will cleave. Again, you will end up with what? X1. Right? And this cleaved minus, this substitute. This is already will be there as OH. And this is that. And again this substitute. This is and this is minus. This is should be there. Again OH. That's and this will substitute and this will be. Yes, you will end up with the resonance stabilization of the phenyl. Okay, so that is what this is the structure. Are you all clear? This is what the resonance stabilization, resonance of phenol. Did you all understand, guys? Okay. Okay.
Yes,
Next,
yes, yes.
thank you. Next, we'll go for the reactivity of what? The benzene ring in phenol. Can you say what type of the reaction can be happen in the phenol? What type of the reaction is possible? Anyone? Nucleophilic substitution is confirmed. And what type is, should be possible? Anyone? So what is the type of the reaction can be happen in your benzene? What is the type? The benzene is the electron rich compound, right? Okay. Therefore, they will fond of what? The electrophile. So the electrophilic substitution. Right? Electrophilic substitution. The electrophilic substitution reaction will happen. So the benzene is also like as well as your phenol also able to react undergo the electrophilic substitution reaction. Why? When you compare the electron rich, I said right, the electron rich high. The electron rich always higher than your benzene. The phenol is higher than your benzene. Why is so? So you can see the oxygen has the lone pair. This lone pair further can react, the further can provide the electron for your benzene ring and providing what the more electron rich compared to your benzene. So the phenol is more towards to the electrophilic substitution than your benzene because of what? The production that having the lone pairs in your OH group. That is the reason. Did you all understand? Right? And have you, even though in fortnight examination we have done, hopefully you all should remember the monosubstituent group, right? The directing ability of the monosubstituent groups we have studied. Anyone can remember? Right. If you want to perform any reaction, right? If you want to substitute, we know the benzene always undergo for the electrophilic substitution. Whenever you speak about the electrophilic substitution, right? So when you want to do the substitution, who is this? Yusuf? Is it Yusuf? Hello? Hello? Yusuf? Who is this? He came again with. Okay, right. So, we have studied the directing ability. If you want to substitute any group, we will say NO2 to the monosubstituent group, monosubstituent benzene. Do you know where this NO2 should substitute either this place, ortho position, meta position, or para position? Which place? So, The substitution of the second substituent group on your monosubstituent benzene will be decided by what? The first substituent group which is present in your benzene. We have studied that one. So we have studied different two directing groups. One is the meta director, the other one is the ortho para director. Anyone can remember? The OH is, it will activate the electrophilic substitution, and OH also will lead to what? Yes? Ortho para electrophilic substitution. Are you all clear? Just that. Is it clear? There is two reaction, right? There is two reaction. One is the reaction of the phenol with Br2 and the nitration reaction, right? Nitration means what you know, having NO2 and reaction with Br2 what? The substitution of the Br. That's all. So let's do the reaction of the phenol with Br2. So what is happening here? Let a phenol react with, yes, Br2 liquid. That is very important. When a phenol react with Br2 liquid, which line I wrote? You will end up with 2, 4, 6 tribromophene. My answer. Let's say grow the phenol. So this is phenol, it's a monosubstituent group. What is the first substituent here? The first substituent is, can you give me a second? Where is all? This be underlined, right? Okay, right? So when the phenol, right, who is the first substituent? OH group. So I said the phenols are ortho para directors. When you use the Br2 liquid, what should be the answer? 246. How would you find this 246? This is your benzene ring. If you say this is one position, this is 2, 3, 4, 5, 6. And they clearly said 246 tribromo. So 3 bromine should be added. 246, the position is said. What is that? Can we tell you? Yes. Yes, what is the position here? 2, 6. Ortho position. 4. Para position. Right? So you will end up with 3 answers. Sorry, 1 answer. Should be what? Tribromo. The OH is there. Here one Br, another Br, and this is also Br. Orthopara substitution, and you will end up with white color substitution. This is what the identification of the phenol. This reaction we are calling as what? The identification of the phenol. Did you understand? If you want to find whether the sample is having the phenol, once you add the Br to liquid, you will end up with what? This 246 trichromophenol, right? Therefore, you will get the white color. And we already studied, right? When the benzene, right, react just with the bromine, right, there is no any reaction, right? Because of this monosubstituent, because of this phenol, you are ending with this result. Are you all clear? Yes, guys, are you all clear? Hmm? You should be very careful about that. If you have been, is this the recording started? Guys, are you all clear?
Yes,
Ah,
yes.
Mr. Shahid. Are you clear? Yes.
I have to read the notes once more.
Sorry. You have to study. So did you understand? Do I need to do it again? That is the question.
Yeah, okay.
That is clear, right? And give me a second, guys. We will do the next reaction. After that, I'll finish the class. So this way also we could not start the aldehyde ketone and I didn't send it right. It got stuck like this. Okay. And let me move on to the. Okay. So guys, whatever the presentation I shared in the WhatsApp, if you couldn't see, doesn't matter. How? So if you couldn't see, it doesn't matter, guys. I already uploaded in the WhatsApp group. Sorry, MS Teams, right? You just have a check on that. All are there. So now you can take what? Which one? Aldehyde ketone presentation. Yes, I found. Aldehyde ketone presentation.
Is Fino finished?
Hmm? Not finished. Wait, wait. We have 15 minutes more.
No. Phenol.
Yeah, phenol finished. Phenol only 2 reactions. You need more. You need more. Uh-huh.
No,
So that's why you better to write and keep. Then you can remember. Phenol having only just a
no,
2,
miss, I
right?
didn't take no, notes of these notes.
When it's already completed. This is what is the call from your right, guys? I don't want to say it. You all should realize it. Okay, so what is the date today? Today's
This benzene notes yesterday I took print out.
should be like that definitely. I appreciate you all. Happy, really happy. Don't say such kind of thing, guys, right? Whatever I send before the class, you should take, right? Okay, right. So I have shared what clear drawing. I have shared that aldehyde ketone presentation. Can you all see in your WhatsApp group? And you can check your MS Teams. There is a channel called the Organic Chemistry. And that also I have done that one. Okay. It's already uploaded. All notes are there. Hmm? The first thing is we have to start with what the aldehyde ketones and you should say the board is here. Can you draw the compound of the aldehyde and the compound of the ketone? Quickly. Anyone? Mr. Shaheen and the Zain. Who is this? This is Shaheen. Yes. Hmm. Draw. Only this is. Huh? Hmm. Yes, but you never. Yes. Okay. And this is very important. You should not forget. You have to add R. Yes, you are writing. Okay. And this should be R. Okay. Good. So you know what is mean by the aldehyde and ketone. Zain, are you clear? You know that the compound? Yes.
Yes, yes.
So actually we already know. So I will clear all, right? Okay, guys. So the basic thing is here we are going to speak about what the compounds having oxygen containing compound. The unit 9 is for what? Oxygen containing compound. So when you speak about the oxygen containing compounds, that's why we studied alcohol and phenol that has the oxygen. Seems to be similar structure, so we have studied together, right? Okay, that is one thing. So oxygen containing compound, what is others? Yes, you are having the carbon and carbon group, CO bond. The CO bond, yes, the aldehyde and ketone, what is the common thing is they have CO bond with hydrogen and having, yes, alkyl group. And the ketone is having two alkyl group in between the CO bond. And though this carbon, both carbon is, what is the hybridization? Yes, guys? What is the hybridization? sp2. So now we are going to speak about what? Under the oxygen containing compound, we already done the alcohol and phenol. Now we are going to speak about the carbon and carbon having the sp2 hybridized compound, that is aldehyde and ketone. And after that you have the carboxylic acid and the carboxylic acid derivatives. Under carboxylic acid derivatives, we are studying esters, amide, yes, acid chlorides. These are the things we are studying here, right? Are you all clear? Okay. So here, we start the physical properties. Can we start and finish it? Yes. We can start the physical properties and can finish by sharing the presentation. And give me a second. I will share it. Where is it? Chemistry presentation. Okay, guys. But don't shout.
No, dia not click no. Dia na mulichu.
Okay, fine, I'm coming. Okay, guys, can you see the PowerPoint presentation? I can't share the screen. Can you see the Can you see, guys? Wow.
Yes, miss.
Give me a second. I stop share. Okay. Use the slideshow. Okay. This is so I will finish that part and class. So now we are going to do the physical properties. This is oxygen containing compound having the structure, properties, and the reaction of the aldehyde and ketones cation. Yes, this is right. And the contains, right? First, we are going to speak about the physical properties and the reaction of the aldehyde and ketones. Under that, okay, your Aldehydes and ketone, we are going to speak about what the nucleophilic addition reaction. Under the nucleophilic addition reaction, you have the different reaction. One is the addition of the hexane, the reaction with the Greenland reagent, and the reaction with DNP, Brady reagent. Those are the very important. Self-condensation reaction. Okay, so don't rush. Okay, this is I already given the introduction. I need the physical properties. Okay, can you all see the presentation? Right? Okay. So here again, guys, when you speak about the physical properties, I use the annotation, I can write. Okay. So guys, so this is what when you speak about aldehyde and ketones, right? You can see here the boiling points of the aldehyde and ketones are higher than those of the alkane of comparable relative molecular mass due to the intermolecular dipole-dipole interaction. And you should be very careful about that, guys. We already used to speak about this again and again. Yeah. When you speak about the properties of the alcohol we talk about what this is. It has the hydrogen. Right? Wow, right? So when you compare for the alkane, the same comparatively same molecular weight, the aldehyde and ketone able to possess higher boiling point. So always I am speaking about what the bond, the intermolecular interaction which is able to produce. So compared to the alkane just a London dispersion process. Very weak intermolecular force. Hydrogen bond is the strongest one. So comparatively, the aldehyde and ketone able to produce the dipole-dipole interaction. Right. Because of this interaction, guys, okay, because of this interaction, it shows the highest boiling point. Why? As the bond interaction is high, the bond will also strong. Therefore, you have to provide the more energy to break the bond. That's why the boiling point also high. Did you all understand? Did you all understand? Are you all clear? Statement. However, I already said when you compare with the alcohol, right? The aldehyde ketone shows lowest boiling point. Why? I said the alkane, right, is higher than aldehyde and ketone. Always when you speak about the physical properties, we are talking about the boiling point. What is the basic of the boiling point? Yes, the intermolecular forces. When you speak about the intermolecular forces, guys, the alkane able to force the London dispersion. You have to buy heart this. This is very important. Which is the very weaker intermolecular force. Compared to this, it's a dipole-dipole interaction, the presence of the CO. This is, I said, the most strongest intermolecular forces is the hydrogen bond. Therefore, along these things, the strongness of the intermolecular interaction also increases. Therefore, the bond strong also increasing. So, there to break down this bond strength, you have to provide more energy. As you provide more energy, what will be happen? The boiling point also increasing. Are you all clear? I didn't start recording. It's recording, right? Yes. Are you all clear? Yes. Are you all
Okay.
clear? Thank you.
Yes.
So, okay, I have 10 minutes. Before 10 minutes, I will finish. So this is what, okay, hydrogen bond, and I'm just talking about this here. And keep your eyes, just look at very carefully, right? Okay, so here what is happening, the ethanol, right, your aldehyde, you can see the relative molecular mass. So comparatively, ethanol and ethanol, nol is what? Yes, again I can use, right,
Ketone.
here, ketone,
Ah,
alcohol,
wait.
ethanol is aldehyde, right? When I speaks about the aldehyde, you can see this is 44, 46. Relatively equal. We are speaking like that. Comparatively equal, right? So if there should be one or two is difference, it doesn't matter. And take the propane. This is alkene. Take these three and check your boiling point. Yes. Alcohol shows the highest one compared to what the ethanol, your aldehyde, your alkane is the lowest one, right? Why we are telling, according to this, alcohol is the hydrogen bond, yes, ethanol is the dipole-dipole interaction, and your propane is the London dispersion, the weakest. So this is what the boiling point difference. So this is what is the reason you used to get such kind of the question. So once you read, look at that compound, you're able to say yes, having the alcohol, having alcohol, they're able to possess a hydrogen bond, which is the highest intermolecular forces. Therefore, the boiling point is increased. Why? You have to provide more energy to break down the molecule, right? Okay, so seems to be similar. You can see the relative solubility also. Yes, when you take the alkane is the non-polar one compared to what? This ethanol and the ethanol. So their water solubility is high. So what? How would you get the idea about this thing? You just look at this. Why I'm giving this tabulation? You don't understand, guys. Just look at this one. So once you check this compare, once you do the comparison, then you will understand. So take this next three. Okay, next four is there. These all are right. Propane, propanol, 2-propanol, butane. Again, yes. What is this 1-propanol and the 2-propanol? Anyone can remember? Yes. As the branching of the molecule is increases, the what? The boiling point is decreasing. That is the difference between the alcohol. When
Where
you
the
take,
substituent group is located.
yeah, as the branches is increases, the surface area will be decreased. Therefore, what? The non-polar alkyl group part is increasing, which leads to what? The decreasement of the boiling point. Right? This is what the difference. And when you go for the alkane, the boiling point is 0. The butanol, yes, 76. The ketone is somewhat is high. Here, this is all one set of analysis. You should able to understand. You have to select that group-wise group, and you should able to categorize, and you are able to say the reason why it's giving such kind of the reading. What is the reason in your own you are able to implement the answer. Did you all understand?
Miss,
Did you all? Yes.
when branching increases,
Yes.
the boiling point decreases.
Decreasing. Yes. The alkyl non-polar alkyl part is increasing. So that means comparatively to your OH group, your alcohol, the first slide is showing clearly. That is the reason. You have to give the reason whenever they ask the question. You should compare like that and say. So this is what they are going to give. Why I have given this table, you should understand. Just looking the table and categorize along with yourself and try to find the answer. Are you all clear, guys? Okay, this is what we are talking here. Boiling point and the water solubility of aldehyde and so. It's given in the table. So here, however, we said the ketones participate in the intermolecular forces. Why? The ketone also able to produce the intermolecular forces with water. That's what we are telling is hydrogen bonding, right? So this is what we are telling is therefore aldehydes and ketones with relatively lower molecular masses are soluble in the water. Are you all clear? Why? This aldehyde and ketone able to produce. Why it has the CO bond? The O bond is there. They're able to produce. Okay, again I will use that. Okay. So look at here, your CO bond, right? So it's able to oxygenate air. This is your water molecule, right? This is your water. The water and the aldehyde plus ketone. They're able to react with the water by making the hydrogen bond. And they are telling the lower molecular weight, that word is very important. The lower, relatively lower molecular masses, it's soluble in water. Why? As the alkyl non-polar group increase now, the solubility also will decrease. Non-polar part increases means the solubility also will decrease. So here, that's why they are telling is lower molecular mass will lead to what? The soluble in water by making what? The hydrogen bond with water. Are you all clear? Are you all clear? Yes, sir.
Okay.
Okay, thank you. Hopefully, guys, we have completed the physical properties of. Yes, we have completed the physical properties of the aldehyde and ketones. Now, so tomorrow we will have. Inshallah, Monday, I will start with what the reaction of aldehyde and ketones. So
Miss,
this
tomorrow
week,
why Miss you don't have class?
I ask you all to do the question paper and send me. Actually, reason is, yeah, I'm not at home. I have work. So I thought to do the, but fortnight exam paper, I already explained you what is the reason for that, right? Again now I should stop.